Hello, welcome to the next video. This is question 9. Question 9 deals with this video will deal with significant figures and density calculations. So let's look at question 9. And it says, perform the following calculations. We're going to do A, B, C, D, E, F, and G, as well as number 10. So, 9A. It reads, find the density of a rectangular piece of metal with a mass of 48.5 grams and dimensions of 2.0 centimeters by 3.0 centimeters by 7.0 centimeters. Well, I know that density is mass divided by volume. I can find my volume by having length times width times height multiplied. So I can do 48.5 grams divided by 2.0 times 3.0 times 7.0, and these are all centimeters. So then I will end up with centimeters cubed. So you can multiply these and divide 48.5 by that answer, and that'll give you the density. B. B reads, find the volume of a substance with density of 1.79 grams per milliliter and a mass of 34.5. Well, I have my density equal 1.79 grams per milliliter, and my mass is equal to 34.5 grams. So I need to use my equation, D equals mv. I need to rearrange it so that I can solve for v. I can do that by multiplying by v on both sides. Then I will have d times v is equal to m. Then I can divide by d. That'll cancel that out. So then I have volume is equal to mass divided by density. So I can do 34.5 grams, divide that by 1.79 grams per milliliter. The grams will cancel out, and the milliliter will be divided by a division, so that'll give you a multiplication, so it'll end up with milliliters. And you can find that answer. C. Find the mass of a coin with a volume of 0.75 centimeters cubed and a density of 2.73 grams per centimeter cubed. So again, I have my density equals 2.79 grams per centimeter cubed, and I have my volume equal to 0.75 centimeter cubed. So I need to use my equation once more. This time it's going to equal mass. So I have density equals mass divided by volume. I can multiply by volume on both sides. So give me density times volume will equal mass. So I can multiply 2.79 grams per centimeter cubed by 0.75 centimeters cubed. This will cancel out the centimeters, and I will end up with the grams. D. A measured mass of an unreactive metal was dropped into a graduated cylinder half filled with water. The following measurements were made. What is the density of the metal? And we did this. So I have the mass of the metal, which is 27.275 grams, and I have the volume initial and the volume final. So then Initially, my volume was 1.4 milliliters. My final volume was 15.8 milliliters. If the metal will account for the change in volumes, then if I subtract the final, if I subtract the initial from the final, so if I do 15.8 milliliters minus 11.4 milliliters, that'll give me the number that I need to divide my mass by. So I'm going to do this. Density is equal to mass divided by volume. So my mass will be 27.275 grams. And I'm going to do 15.8 milliliters minus 11.4 milliliters. When you run those numbers, it'll give you grams per milliliter. F. Convert .5 meters to centimeters. Well, I know that centi means 100, and I'm going from big to small, so I'm going to get larger. So then I would multiply the 12.5 meters by the centi. So let's set that up. So we'll have 12.5 meters going to centimeters. So I'm going to do 12.5 meters. And I know that in 1 meter I have 100 centimeters, or 10 to the second. So then I can multiply that and give me an answer. Oh, I'm sorry, this was E. I got ahead of myself. Here we go with F. I'm sorry, apologize. 8.7 grams to kilograms. Well, I know that grams is the base unit, and I'm going to kilograms. So I'm going from a small to a big. That means my answer will become smaller. So then, let's see what that means. 8.7 grams. I have to go to kilograms, and I want to get rid of grams. I know that in 1 kilogram, there are 1,000 grams. So I'm actually going to divide 8.7 by 1,000. This will give me my answer. This will be in kilograms. And the one above will be in centimeters. G. I have 42.0 milliliters to nanoliters. Nano means 9. So then I'm going to do 42.0 milliliters times. It's a two-step, because I'm going from milliliters to liters. So in 1 liter there are 1,000 milliliters, and in 1 liter there are 1 billion nanoliters. So the way we did it in class, if it was times 10 to the third and times 10 to the 9, I can't do these twice, so then I would do this 9 minus 3, that equals 7. And remember that I'm going smaller, so I would have to move my decimal. But that's just a little side on how we did it in class. So you can still do this divided by that times that. H. I'm going to convert 5.32 kilograms 2. Do you guys remember that symbol? Micro. So then we have 5.32 kilograms. This is going to be a two-step problem, as there is no direct conversion from kilo to micro. So I know I have to get rid of kilogram. So in 1 kilogram, there are 1,000 grams, 10 to the third. And then here, in 1 gram, there will be times 10 to the 6 micrograms. Alright, last 4 problems. Significant figure, everyone's favorite. Determine the number of significant figures in the following measurement. I have rules for significant figures. Leading zeros don't count. Trailing zeros count only if there's a decimal. Zeros between 2 non-zero digits do count, and non-zero digits always count. So, here I have 20.00. I have a decimal and I have trailing zeros. Because of the decimal, these zeros do count, so then I would have 1, 2, 3, 4 significant figures. B, these are all non-zero numbers, so they all count. I have 6. C, I have a decimal. That means that any trailing zero will count. I also have 2 non-zero digits and zeros in between those digits. In this problem, all the digits count, mainly because we have the decimal and the trailing zero would count. Here, I have trailing zeros, no decimal, so only the non-zero digit counts. So that's a 1. Oh, and sorry, here it was 5. 1, 2, 3, 4, 5. Alright, I hope that was helpful.